this video, I'm going to be going over an example of how you can make an ERD from scratch based on a set of requirements. So once again, ERD stands for Entity Relationship Diagram. In this case, we're going to be exploring an example of making a database for a doctor's office. But before we get started, there are some things you should read or watch before you start in on this video. Those are Chapter 5 from your text, Database and Content Management, Knowledge Extension 6, Database Design, and those how to create the ER diagram tutorial slides. I'd also recommend watching over my What is an ERD video before you start this one. So let's get into it. To create an ER diagram, there are 7 steps we should follow. Step 1. Collect and review all the data available. Usually this is data that we have gathered from the users in requirements gathering process. Step 2. Identify entities and attributes and draw them on your ER diagram. Step 3. Identify the key attributes and underline them on your diagram. In this case, the key attributes would be the primary keys. Step 4. Decide on the relationships and draw lines between the entities, including any attributes of the relationships. Step 5. Decide on the cardinality of each relationship and add it to the diagram. Step 6. Decide on the participation of each entity in each relationship and add if required. Step 7. Add the foreign keys of each relationship for each entity and add relationship attributes if they are present. So if you're not familiar with some of these terms like cardinality, participation, or even foreign key and primary key, I strongly suggest you look over those readings again, especially the tutorial slides that are now on OWL, as they go over all of this and some of the things we'll be needing to know to follow along with this tutorial. The example scenario we're going to be following in this tutorial is that of a fictional doctor's office. At this point, we're going to assume that requirements gathering has already been completed. So in real life, it's extremely important to gather the requirements for your information system from the actual users of that system. And this requirements gathering process is a big topic in software engineering, but it's a bit out of the scope of this course. If you are interested in this, there are a lot of software engineering resources available that discuss the process in depth. For now, we're going to assume that it's already been done, and we have a list of requirements that our database design has to account for. First requirement is that the system has both nurses and doctors. Nurses work for a doctor in the office. Each nurse works for or is assigned to a single doctor. Each doctor has at least one nurse, but they may have more. So we could have multiple nurses assigned to a doctor, but we know there'll always be at least one nurse working for a doctor. Every nurse has a first name, a last name, and a unique ID. Similarly, doctors also have a first name, a last name, and a unique identifier. Only a doctor can order a test, but not all doctors have to have tests ordered. So that means some doctors may have never ordered a test in the system. Each test has a unique test number and a name of a test. So in this case, the name of the test would be the type of the test. So it could be like an MRI, an ultrasound, or a blood test. If known, we want to keep track of the hours per week a nurse has worked. We also want to keep track of the date any test was ordered. So this 9 things are our requirements, numbered 1 to 9. And they are going to be what we're going to be following to make this entity relation diagram, which is eventually going to become our database. So let's start with steps 1 and 2. Step 1 is to collect and review all the data. Step 2 is to identify entities and attributes and draw them on your ER diagram. So in this case, we can look at requirements 1, 2, and 6. Nurses work for doctors in the office. Each nurse works for a single doctor, and only a doctor can order a type of test, but not all doctors order tests. So from this, we can identify some of the entities. I've highlighted them here in green. So from that, we're going to need a nurse entity, we're going to need a doctor entity, and we're going to need a test entity. So these are all what we call object entities. They represent usually a physical thing or something that we're trying to keep track of. In this case, doctor, nurse, those are actors in the system, and test would be something that's being ordered by the doctor. So next step is or as part of step 2, is to identify all of the attributes associated with these entities. And if we look at our requirements again, in this case 4, 5, and 7 shown here, we can see that there's a few attributes that are required. So we say that a nurse and a doctor both have first names, last names, and a special unique ID. Tests similarly have a unique ID, and they also are going to store the name of the test, which is also sort of the type of the test, since it's going to be MRI, blood test, things like that. So we can take all these attributes and write them under each one of our entities. So for nurse, we have nurse ID, we have last name, we have first name. For doctor, we have doctor ID, we have last name, first name. And for test, we have test ID, and we'll call it type. This is sort of the name of the type of the test. So this is a very simplified list of attributes based on the ones we have in our requirements. In real life, there'll likely be far more attributes for a real system. The second part of step 2 is taking these entities and drawing them in our ER diagram. So what we can see right here is an example of one entity in an ER diagram. So entities are represented by a box like this. The top of the box, shown right here, is the name of the entity. And we always want to write this in all capitals to denote that it is the name of the entity. The second part of the box, beneath it, is a list of the attributes in the entity. So what we are doing right now, we're just taking all those attributes we identified, all the entity names we identified, and making a box for each entity, and putting the attributes that we found in each box. So the next step is to identify the key attributes and underline them on your diagram. So this means we have to identify the primary keys. So primary keys should always have a unique value for each instance of an entity. So for example, we can see that we could have first name, for example, for a nurse as a primary key, and that would cause some problems because we could have nurses with the same first name. We could also have last name as a primary key. That might be fewer nurses with the last name, same last name, but it is still possible. It's even still possible if we were to combine these two, first name and last name, that we could have some rare instances where we have a nurse, or two nurses rather, that have the same first name and last name. So we can't use those as primary key, but there are some other candidates here. And a key thing we should look at is the actual requirements that we're given. So in this case, requirements 4, 5, and 7 each have something that's important to note. They state that each nurse has a unique nursing ID, and each doctor has a unique doctor ID, and each test has a unique test number. So this is a big clue that these are going to be unique values that could be candidates for our primary keys. In this case, it's also the only thing that's guaranteed to be unique. So this is what we're going to be using for our primary keys for each entity. And to denote that they're primary keys in our diagram, we underline them or draw a line under them like this. I've also highlighted them in blue here for your convenience, but all the colors that we're going to show in this tutorial, they're not needed in your own ER diagrams. They're just for illustrative purposes. So the next step, we need to decide on the relationships and draw lines between the entities. So we have nurse, doctor, and test. So we need to come up with what are the relationships between these entities that we can see on the screen right now. So again, if we take a look at the requirements, we can see that nurses work for a doctor in the office. So the key here is works for. We also see that only a doctor orders a test, and not all doctors have tests. So we can see that the relationships here are going to be works for and orders. So a nurse works for a doctor, and a doctor orders a test. We can also read it the other way, which would be a doctor is assigned a nurse, and a test is created or ordered by a doctor. But the key thing to note here is that we have two relationships to consider. The works for relationship between nurse and doctor, and we have the ordered relationship between doctor and test. So we can start by just representing that as a line between the entities, and with some text above it that describes the relationship. So we should always have some text above each relationship, just so we know what it is. So for the second part of step 4, we also want to identify and include any attributes of the relationships themselves. So these are relationships not of the entities, but of the actual relationship between entities. So in this case, there are two requirements, 8 and 9, that give us some clues about what the attributes of these relationships are. So the first one is we want to keep track of the hours per week worked by the nurse. So that is going to be specific to the works for relation. And for now, we're going to just denote that with an hours per week in a circle, and it's going to be drawn to the relationship. So this is just going to be temporary until we can fill them in later. And similarly, we need to know the date that a test was ordered. And this is going to be an attribute of the orders relation. And again, we're going to denote it simply with a word date in a circle, and it's going to be pointing to the orders relationship. These will be temporary because later on we're going to be actually including these somewhere. They can't just be left hanging. So on your own ER diagrams, make sure you never actually end up with any of these attributes in circles, just sort of pointing to relationships. By the time we're done, these should all be included somewhere inside of some entity. But for now, in this step, we just want to visualize this as an attribute of the relationship. It'll help us later on in the future steps. So in the next step, we need to determine the cardinality of each relationship. So by cardinality, we mean what type of relationship is it? Is it one-to-one, one-to-many, or many-to-many? Once again, we need to take a look at the requirements to get an idea of how to set this up. So we have each nurse works for a single doctor. We have every doctor has one or more nurses. So this gives us a bit of a clue at what the cardinality of this relationship is going to be. So first we'll take a look at the nurses side, and we're going to be using the single symbol, or the one symbol, to denote that this is going to be a nurse working for one doctor. The way we read this is always from the entity we're talking about, in this case a nurse, over to the other side of the relationship. So this says the nurse works for one doctor. So in the doctor's case, we have the doctor has one or more nurses. So to denote that, we're going to be using the many symbol. So this symbol means that it's many on this side of this relationship. The cardinality is many. So the doctor is assigned many nurses. So this is a one-to-many relationship from the doctor's side. So the doctor is many, and the nurse is one. So now we need to figure out what the relationship is going to be, or what the cardinality of the relationship is going to be for the orders relation. And the information that we have about that isn't very clear. It's a bit ambiguous. It says only a doctor can order a type of test, but not all doctors can order tests. So we're going to have to use a little bit of common sense to figure this one out. So we know that a doctor is probably going to want to be able to order more than one test. Because if they could only order one type of test, that wouldn't be very useful. Doctors need to be able to order blood tests, as well as MRIs, a variety of tests. So we can safely assume that this side of the relation, that would be the doctor side, we're going to be saying the doctor can order many tests, is going to be many. Going the other way, it's also going to be a many relationship, because we're going to want many different doctors to be able to order different types of tests. It probably wouldn't be a very efficient setup if only one doctor could order MRIs, only one doctor could order blood tests, and so on. So we want tests to be ordered by many different doctors. And again, we read it going from the entity up the relation. So in this case, this is applying to test. So this many symbol means many tests can be assigned or be ordered from many doctors. So for example, both doctors A and B could order the same kind of test, for example, an MRI. The next step, we need to decide on the participation for each entity and in each relationship. So by participation, we sort of mean the minimum requirement for that relationship. So we can start again by taking a look at the requirements. In this case, we have each nurse, again, works for a single doctor, and we have every doctor has one or more nurses. So this again is slightly ambiguous. It doesn't say if there could be any nurses that aren't assigned to a doctor, but in this case, we're going to assume that all nurses are assigned to at least one doctor. We're going to get a 1. So in this case, this 1 symbol is denoting that a nurse has to be assigned to a doctor. We can't have any nurses that are not assigned to a doctor. Well, the other one, or the other singularity symbol, denotes that a nurse cannot be assigned to more than one doctor. Again, remember that we are reading it from the nurse over, so that is denoting the participation for the nurse and not the doctor. It can be a bit confusing because the symbol is near the doctor, but it is always for the one over here. It's like if we're following the line, it tells us what the cardinality and the participation is. So when we talk about the doctor, we're also going to get 1, and because it clearly says 1 or more. So each doctor has to have at least 1 nurse assigned. So in this case, the symbol is referring to the number of doctors that number of nurses a doctor has to have. So in this case, a doctor has to have at least 1 nurse. There can't be any doctors that aren't assigned to any nurses. Every doctor always has to have at least 1 nurse. Well, the many side beside it means that a doctor could have more than 1 nurse if they wanted. Now we have to determine the participation for the orders relationship. In this case, it's going to be a bit more ambiguous, and this is similar to more what you would get in real life. You often aren't going to have requirements that are written from users in terms of 1-to-1, 1-to-many, many-to-many, and say that there has to be at least 1 nurse or at least 1 doctor, things like that. So a lot of times you are going to have to be able to decode these. So in this case, we have to use a little bit of common sense. In this case, we know that a test is always going to have to have been ordered by a doctor. So there can't be any tests that aren't ordered by any doctor. So that would be a bit weird. So by the symbol we see up here, we're saying that a test has to be linked to 1 doctor. There always has to be at least 1 doctor that ordered this test. The other way is how many tests a doctor has to have. And by this 0 symbol, this sort of empty symbol, we are saying that a doctor can have no tests, because we may have a doctor that's never ordered a test. They could be brand new and not ordered any tests yet. So a doctor doesn't have to have a test assigned. So that's what this symbol here is saying. Not all doctors need to order tests or have tests already ordered. And this comes straight from our requirements, but it's also something we could probably figure out with just using common sense about the problem. So in step 7, we want to add foreign keys for each relation, for each entity pairs, and add relationship attributes if present. So we're going to start off by working with the foreign keys for the works for relation. So we have to remember this rule from the other set of slides, and that is a rule for relationships that are 1 to n, that's 1 to many. If one side's many and the other side is 1, then the one entity must receive the foreign key. So in this case, if we take a look at the relationship, we can see that we have a many over here, and we're talking about the cardinality, not the participation. So we have many here, and we have 1 here. So what we mean by the 1 entity would be the entity that has a cardinality of 1. And remember, we don't say that just because this many is beside the nurse, that they're the many one. We read it this way. So in this case, the nurse would be the 1 entity, while the doctor would be the many entity. So since the nurse is the 1 entity, we are going to add the foreign key for the relationship to the nurse's list of attributes. So the foreign key is going to be a link with the doctor's ID. So we take the doctor's ID, and we're also going to have that as an attribute for the nurse. So recall that this doesn't have to be named the same thing as in the doctor, as long as we know that this is a foreign key and it's what links us to the doctor in this relationship. So it's usually easiest to keep the same name, but we will see some examples, like in the other slides, where it's not always the same. But it should always be clear in your diagrams. So now we have to deal with that relationship attribute. And that comes from that requirement that if it's known, we have to have the hours per week for a nurse. So right now, that's part of the works for relationship. And a rule that came from our other slides about creating ER diagrams is that relationship attributes always follow the foreign key. So in this case, the foreign key was this doctor ID that we added to nurse. So it's going to follow it to the nurse and become a new attribute in the nurse's entity. And then we can remove that hours per week line from our works relation because we now have it in our nurse entity. So now we have to deal with that orders relationship. And this is going to be a little bit more complicated because it is a special case. And this is a special case. We're going to call this step 7b, where we're dealing with or resolving the many-to-many relationships. The reason why this is a special case is it's because we are going to be required to create a new entity called a relationship entity. So the first step is to create that new entity, and we're going to give it the same name as the relationship. So in this case, orders. And it is important that the way we type out orders in our ER diagram is all lowercase. And this denotes it from normal object entities like doctor. Instead, for relationship entities, they're going to be all lowercase. And the attributes of this new relationship entity that we created are going to be the primary keys of the two entities that are on either side of the relation. So in this case, we have doctor, and it has a primary key of DoctorID, and test, and it's going to be TestID. So these both come over to our orders entity, and they become foreign keys in this order entity. And it's basically what's going to link it to these other entities. So right now, when we're starting, the only attributes for our relationship entity are going to be the primary keys from the two entities on either side of the relation. And these will become our foreign keys in the orders entity. The next step is to determine the participation and cardinality for this new orders relationship. And we do that by simply copying it over from the existing orders relationship. So in this case, the doctor side of the orders relationship, we're just going to copy over the doctor's participation and cardinality. Remember that it's always on the opposite side. So the participation and cardinality for doctor is right here. I'll copy that over. Similarly, we're going to copy over the test, participation and cardinality, and put it on the test side of our new orders relationship entity. Now we have to determine what the participation and cardinality are going to be on these ends. And there is a rule for this, and that is when it's a many-many relationship like this, it's always going to be 1 and 1. So 1 participation, 1 cardinality on both of the far ends. And then we just replace the existing orders relation with this new relationship with the relationship entity inside. So this is what the relationship will look like after we've replaced it with a relationship entity. And this is sort of a temporary table that's going to hold a doctor ID and a test ID for each connection between a doctor and a test. The reason why we have to do this is we can't simply put a test ID as an attribute in the doctor because it would only be linking to one test when doctors can order many tests. Similarly, we can't simply put a doctor ID in the test because each test can be ordered by multiple different doctors. So we have to have this sort of connection table that holds each instance of a connection in it. But we also have this date attribute that's sort of hanging out over here that we have to resolve before we can be finished. And for many relationships, after we've actually made this relationship entity, it is quite easy to resolve. It just follows the foreign key. In this case, the only foreign keys are in the orders table, and they are both the doctor ID and the test ID, so it just follows them into the orders entity. So when we have many-to-many relationships like this, and we have a relationship attribute that was to that many-to-many relationship, it always goes into this new relationship entities table. And that would look like this. So now this table holds both 2 foreign keys to link them together, as well as the date that that test was ordered. If we wanted to be more complex, we could add in more attributes about what the results of that test may have been. But for our case, we only have specific requirements, and they say we only need to record the date that that test was ordered. We don't have to have any of the results in there. So now we can see everything put together here, and this is our completed ERD. So we have that nurse's entity back, as well as the works for relationship. That's that many-to-one relationship between nurse and doctor. Now, this is our completed ERD, it's all done. However, there might be a question you might have if you look closely at that orders entity. You can see nothing's underlined, which means there's no primary key. And that's perfectly fine for relationship entities. All other entities, normal entities in our ERD, should have a primary key set. However, relationship entities are not required to have primary keys. So this is only allowed for relationship entities. So do make sure your normal entities all have a primary key set. And this will work fine when we go to access in later weeks when we turn this into a database. It accepts that the relationship entities can have no keys. And it also means that a doctor can order multiple copies of the same test. If any of those were set to unique, like primary keys have to be, we might have issues where a doctor could only ever order one test, or they could only order one type of test once, which we don't want to run into. The other thing I should mention is that in this video, as well as the slides used in this course, all the foreign keys in these ERDs are marked in italics. However, this isn't an official convention, it's just something I'm doing in the slides and video, just to make it easier for you to visualize what's a foreign key and what's a normal attribute in these entities. So don't worry about doing this in your assignment because DIA doesn't really have an easy way to do this. Another thing is these bullet points that I'm zooming in here on now. These are important. They're not just arbitrary bullet points, and they all have a different meaning in DIA. However, unfortunately, the meaning is sort of dependent on the ERD tool you're using or the style you're using. So in these cases, these are the bullet notation used by the DIA editor that I recommend using for the class. So if you're using a different editor, these bullets will look slightly different, but I'll go over what they all look like if you're using the DIA editor. So the three main ones that we'll see are diamond, and the diamond here indicates whether this is a primary key or not. So when we see the diamond bullet, it means that this attribute is a primary key. When we see just a filled in circle right here, it means this is a required attribute. This is an attribute that any instance of this entity has to have. It can't just be blank. And the empty circle is the exact opposite of that. It's what we call a nullifiable attribute, or a null attribute. It's an attribute that's allowed to have no value. So in the example that we saw, we said that only if it was known the hours a nurse worked, it would be included. So then in that case, the number of hours a nurse worked, and we'll just go back and take a look. You can see that it has the empty circle. And that's because in some cases it might not be known and it might not be filled in. In that case, that would be a nullifiable attribute, one that can have no value in the database. So if you're using the DIA editor, the way you can set these different qualities or different properties of an attribute would be in the Properties tab when you're on a entity, and there are different sort of checkboxes that you can select for primary key, nullable, and unique. And they will produce those different symbols. So there are some general guidelines of when you should use nullable, unique, or primary key. So for primary keys, it should always be no to nullable. We can't have an empty primary key. That won't really work when we're trying to find that record in the database. And it always has to be unique. That is a property of primary keys that we talked about. So for the DIA editor, at least the newest version, when you select primary key, it will actually force you to have no to nullable and yes to unique. So for foreign keys, for nullable, they should definitely be unchecked no if it is mandatory. So if that entity has to have a relationship with some foreign table, it has to be mandatory that it has a value. If it's an optional relationship, then you can check yes to denote that it's optional that it be linked to this foreign entity. For unique, for foreign keys, it should be checked yes if it's one-to-one, and it should be checked no if it's on the many side. So this is going to be based on the cardinality of that relationship. So in general, for nullable, it indicates if the field's blank, you want to check yes, the field can be empty in the database. You check no, the field can never be blank. So it has to have a value. So the general rule of thumb is that must the field have data? For example, a student has to have a last name, so that would generally not be nullable. Or for a student's date of birth, we might not have that on record, so we could set that to nullable if it could be left empty, if the students don't have to provide that. So for unique, this is going to indicate if there could be another entry in the database, another record in the database that can have the same value for that field. So we know primary keys are supposed to be unique. We shouldn't have two records in the same table with the same value for a primary key, but we can also make this property on other attributes. So we want to check yes if that cannot be duplicated, if there's some value in the database or some attribute in the entity table that cannot have the same value. And we want to check no if they can have the same value. So a general rule of thumb is that must the field be unique. So for example, a student locker number, that would probably be unique. We probably wouldn't have two students with the same locker number, so the locker number should be a unique attribute, even though it's not a primary key. If it's possible for students to share lockers or have the same locker ID, then you would definitely want that checked, or unchecked rather, because it would not be unique. So in the next tutorial, we're going to be taking a look at how we can actually make that diagram that we made today in the slides in the DIA editor. So I do recommend that you use the DIA editor for this class and check out that tutorial to get an idea of how to use it. So thank you for watching and have a great day.